Hi, welcome to the Getting Started with the MSP430 Launchpad workshop. My name is Scott Bland, and I'm an instructor with the Technical Training Organization at Texas Instruments. I'm also the author of the material in this workshop. This workshop has been architected to be extensively hands-on, and the majority of your time will be spent actually working with the tools. You should already have some experience with microcontrollers and using the C programming language to get the most benefit from your time spent here. If you don't, there are many resources online that you can use to obtain that knowledge. In case you didn't know it already, all of this material is available at ti.com launchpad-workshop, as shown in the link below. That site has links to all of the material that you'll need to get started. Let's go ahead and get started. Section 1 is an introduction to the MSP430 series microcontroller and its peripherals and tools. You'll see how the MSP430 Value Line series fits into the MSP430 product line and the wider Texas Instruments microprocessor portfolio. TI's embedded processing portfolio stretches from the low end of 16-bit ultra-low power microprocessors with the MSP430 all the way up to high-performance DSP and ARM microprocessors at the top with the C6000 Integra and DaVinci parts. In the center, you'll notice the 32-bit Stellaris parts, the 32-bit Hercules parts, which are Cortex M3 and Cortex R4 parts running together, and 32-bit high-end A8 and A9 Citara parts. Today we'll be working with the Stellaris parts. We're looking at devices up to 80 megahertz, flash from 8K to 512K, a variety of connectivity peripherals on the devices, USB, Ethernet, MAC and PHY, CAN, A to D converters, pulse width modulators, SPI ports. We see these being used in things like motion control, human interface, industrial automation, smart grid, with prices anywhere between $1 and $8. The course today that we're going over is the M3. But there are new parts that are just being announced, the Cortex M4F with a floating point processor on board. We'll go over these a little bit later. There are over 300 ultra-low power MSP430 devices that have been released, starting at about 25 cents US. These feature up to 256K of flash, 18K of RAM, more than 25 different package options with up to 113 pins on the devices with very high integration. The different subfamilies are FRAM, the new technology memory ferroelectric random access memory with speeds to 24 megahertz. We have the ultra low power LO92 series with voltage down to 0.9 volts. In the typical flash parts, we have the 1X, 2X, 4X, and 5X families with speeds from 8 megahertz all the way to 25 megahertz. At the far right, you'll see the CC430 with speeds to 20 megahertz. These parts have up to 32K of flash, 4K of RAM. They also have an integrated RF transceiver inside them, so you can do remote control, you can send information from part to part, you can build networks with them using Simplicity, 6LoWPAN, different kinds of protocols. But the parts that we're going to be working with today are the G2XX series, the Value Line series of parts. Those have speeds to 16 megahertz, and the slide here is a little bit wrong. Flash size goes as high as 16K, and the RAM as high as 512 bytes. With a good number of GPIO, the main thing is these are set to be very low cost. There are more than 40 parts currently available in the MSP430 Value Line. The differences between the parts you can see are mainly the flash sizes, the SRAM sizes. You can see that the flash goes between half a K all the way up to 16K kilobytes. The SRAM is 128 bytes all the way to 512 bytes. The GPIO stretches from 10 to 24 depending on the part type and the package type. The number of timers anywhere between 1 and 2. Those timers can also be either the A2 or A3 versions, A2 having 2 capture compare registers, the A3 having 3. All of the parts have the Watchdog timer on them. Some of the parts have the USCI, the Universal Serial Communications Interface, that has I2C, SPI, and UART hardware inside of it. The USI, the Universal Serial Interface, has I2C and SPI in it. About half the parts have the comparator inside them. About half the parts have the temperature sensor inside of them. On the ADC side, you can see that most of the parts have ADCs, or A to D converters. Most of them are the 10-bit ADCs. Some of them are the slope ADCs. The 10-bit ADCs are successive approximation. Many of the parts have now been equipped with the CapTouch I/O. This is capacitive touch, the PIN-OSC, P-I-N-O-S-C feature that allows you to easily and with just a little bit of overhead implement capacitive touch on your design. You'll notice I have a blue dot next to the 2X31. The 2231 was on the parts, the Launchpad devices that were 1.4 and below. Version 1.5 came out and has the 2253 version. The 2253 has the peripheral shown on the chart there. Power consumption on these devices. You'll notice that we're quoting this at 2.2 volts. The parts, all of the value line parts, will go down to 1.8 volts. But at 2.2 volts, you still have in-system programmability of the flash. So we're going to quote at 2.2 volts where all of the features are there. If you're not using in-system programmability of the flash, you could slide down to 1.8 volts and have a significant power savings. But at 2.2 volts, we're looking at 0.1 microamp RAM retention, being able to keep the RAM available when you start back up. At 0.4 microamps, that's in standby mode. That's with the very low frequency oscillator running. At 0.7 microamps, we have the VLO, or we would have the crystal clock running, and be able to run in real-time clock mode with a little bit of software running to keep the real-time clock available for your system. At fully active, we're talking about 220 microamp per MIP. So if you're running it at 8 MIPS, you're talking about somewhere around 1700 milliamps to run that. 1700 microamps to run that application. That's pretty low. If you're going to make use of a lot of low power modes, and a lot of low power modes involve going to sleep, turning the clocks on the part off, turning the CPU off, then you're going to need ultra fast wake up when an interrupt occurs. So we can wake up from standby in less than 1 microsecond, in most cases substantially less than 1 microsecond. The central processing unit inside the MSP430 is 100% co-compatible with all the earlier versions. It has a full-size 1 megabyte unified memory map, so there's no paging required across the entire memory of the device. The extended addressing modes have page-free 20-bit reach, improving the code density and causing faster execution when you have to access things outside of 16 bits. Of course, on the G-series parts, we will not be outside those 16 bits. Full tool support for the CPU, all of the versions of the CPU, through IAR tools and through CoComposer Studio. The memory map of the MSP430 G2553 looks like the diagram on the right. You can see that the interrupt vector table is pushed up at the top of memory. This is flash, starting at FFFF, going to FFE0. Flash then starts, the rest of flash memory then starts right below that. And on the 2553, that's 16K bytes of flash. So that stretches all the way down to C000. There's a section of information memory. Information memory is broken up into 64-byte segments. Most of the parts have 4 of these, A through D. You can store things in there like calibration constants, MAC addresses, IEEE addresses, any other specific information that you want. Section A of that contains device-specific calibration data that's been factory programmed, and that's lockable as well, so you don't inadvertently go in there and erase that. On the 2553, the RAM starts at 3FF and goes down to 200. Then below that, you can see the 16-bit peripherals, the 8-bit peripherals, and then some special function registers. Programming the flash on this device is available either through the JTAG port or through the in-system by doing it in-system. Programming it inside your code. And like I said earlier, the in-system programmability works down to 2.2 volts. If you go down below that, the charge pump can't provide enough voltage to the flash to make it program. That programming is single byte or word. It's interruptible either on the programming side or the erase side. That flash is broken up into 512 byte segments, 0 to however large your space is. Those are erasable individually, or you can go in and erase all of them. And if you're going to be changing the speed of the part, if you're going to be moving it between 1 megahertz and 16 megahertz, you're going to want to change the timing of the flash memory timing generator so it matches the speed that you have, so you're writing to the flash as quickly as you can without it being too quick. So the flash memory timing generator in this device is completely programmable. Taking a closer look at the Value Line peripherals, let's look first at the general purpose I/O, the GPIO. The GPIO on the Value Line parts are independently programmable. You can write to any single pin or port if you like. Any combination of input, output, and edge selectable interrupt, either going high or going low, is possible on every single pin. Read-write access to the port control registers, the data register, the selection register, the direction register, is supported by all instructions, meaning that you don't have to go and read the port and then read the pin and then act on the pin. You can create a if statement that will read the port control register or the data register and act on it in the same instruction. It saves you a lot of time and effort. Each I/O has an individually programmable pull-up or pull-down resistor. That can save you some on the bill of materials. Some parts and pins are touch sense enabled, meaning they have the pin OSC capability for capacitive touch. If you'd like to implement that in your design, that makes it very simple to do so. All of the parts have at least one 16-bit timer in them. Some of them have two, and the timer versions go between the A2 and A3 version. The only difference between those two versions is the A2 has two CCR capture and compare registers. The A3 has three. There are extensive interrupt capabilities on these things. You can do interrupt when the device, when the timer rolls over. You can interrupt when it reaches one of the counter compare registers. You can do things like simple PWM. You can count events. You can monitor times. You can have the comparator reach in and start the timer, so you time the difference between the time when it reaches the voltage reaches a point and it reaches some other point. So there are extensive interrupt capabilities on here. All of the parts have a watchdog timer. In this case, they're all the WDT Plus that not only implement a 16-bit watchdog mode, and we'll talk about the different timer capabilities it has later, but it's also available to be used if you're not using it as a watchdog. You can use it as an interval timer. All of the devices have brownout reset circuitry on them. This will provide the correct reset signal during power up and power down. So when the part's coming up, it's possible for the ramp of the power to be slightly noisy, to be a little slow. The brownout reset circuitry will keep you in reset for a certain period of time after the resets or after the power